Okay, so this is how we are going to represent an infinite set. So for example, we have set B is equal to 2, 4, 6, 8, and then we should put 3 dots on the last part. That signifies or symbolize infinite. So meaning this set B is a set of even numbers. Did you understand? Next, other example, we have set C is equal to 1, 3, 5, 7, and then we have 3 dots at the last part, and it symbolizes that it is infinite. So this means that set C is a set of odd numbers. Did you understand? Next, we have proceed to equal set. So equal set, from the word equal, they will be equal. So how are we going to know if the two sets are equal? For example, set A is equal to set B. Next, two or more sets with exactly the same number of elements, and the elements are also the same. Take note of the two conditions. We have the first condition, exactly the same number of elements. They should have the same number of elements. And then the next condition, we have the elements are also the same. Did you understand? The elements should be the same. So it means that they are identical. Example, if set A is PQR and set B is QRP, are they equal set? Yes, because we have the same number of elements. We have 3, and then we have the same elements. Okay, it's just set B rearrange the elements of set A, but they are equal. Next, if C is the set of letters in the word Rome and D is the set of letters in the word more, are they equal set? Is set C equal to set D? Yes. It's like the first example, set D just rearranged the word Rome, but they have the same number of elements, and then they have the same elements. Then this one, if set A is equal to 2, 4, 6, 8, and set B is equal to X, wherein X is less than 7, and X is natural even number. Next, are they equal? Are they equal? Yes. So what are the natural even numbers, less than 7? We have 2, 4, and 6. Did you understand? Next one. Equivalent set. So what do you think is the difference between equal set and equivalent set? Let's see. Okay, take note of the symbol. On the equal set, it's just equal, but in the equivalent set, it is a curly equal. You look at the symbol of this one. Okay? So what is the meaning of equivalent set? Two sets that has exactly the same number of elements. So what is the only one condition? It has the same number of elements. Okay, from equal set we have two conditions. It should have the same number of elements and then the same elements. But in equivalent set, it has only one condition, and it has exactly the same number of elements only. Okay, you should know how to differentiate the two. Next example, if set A is equal to XYZ and set B is equal to ABC, are they equivalent set? Yes, because it meets the condition that it has exactly the same elements. How many elements are there in set A? We have 3. How about B? Set B, we have 3 also. So it is an equivalent set. Next one. set A is equal to 1, 2, 3, 4, 5, and set B is equal to A, E, I, O, U. Are they equivalent set? Yes. How many elements are there in set A? We have 1, 2, 3, 4, 5, and set B we have A 1, 2, 3, 4, 5 also. Therefore, they are equivalent set. Did I make myself clear? Excuse me. Oh, I did put my mic a while back. Okay, I hope you can still hear me. Next. Note, equal sets can be equivalent, but equivalent sets cannot be equal. Okay, so when the two sets are equal, they are also equivalent set. Why? Because the condition of equivalent set, it has the same elements, the number of elements are the same, and that is also the condition of equal sets. So it meets the condition of equal set. Therefore, when the two sets are equal sets, they are also equivalent. Did you understand? But equivalent sets cannot be equal. Why? Because it didn't meet the one condition of equal set, which is it should have the same element. Did I make myself clear? Okay, I hope so. Next, we proceed to disjoint sets. What is the meaning of disjoint sets? Two sets which have no element in common. They don't share the same element. Example, set A, E, I, O, U. Set G, B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. Are they disjoint sets? Did they share a common element? No. Therefore, they are disjoint sets. Next, universal set. Okay, before we proceed on that one, if we have disjoint sets, we have also joint sets. If we set joint sets, they share a common element. Okay, we proceed to universal set. The universe or universal set denoted by capital letter U is the set containing all the elements under consideration. Totality of all elements being discussed. Universal set. So if, for example, we have set F, A, E, I, O, U, and set G, we have B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. Our universal set is the combination of the two sets. Why? Because the two sets are a set of alphabets. So, in a whole, or the universal sets are the alphabet. Did I make myself clear? Is the alphabet, I should say. Okay? Did I make myself clear? Thank you. Let's try the following. Equivalent set or not. We determine if they are equivalent set or not. One, set 0NE is equal to set NEO. Are they equivalent set? What is the condition for you to say that they are equivalent? They should have the same number of elements. That's the one condition only. So we count the number of elements on the set 1E. We have 1, 2, 3, and then the other one 1, 2, 3. Therefore, they are equivalent set. Next, how about this one? 2, 4, 6, and then dot 50, and then we have 1, 3, 5 49. Okay, are they equivalent set? Do you think they have the same number of elements? How many elements are there? How many even numbers are there from 2 to 50? How many? How about odd numbers from 1, 3, 5, and then 49? We have from 2, 4, 6, and 50, we have 25. How about 1, 3, 5 until 49? How many odd numbers? We have also 25. Therefore, the example is an example of equivalent set. How about this one? Are they equivalent set? MATH and then TOMA. Are they equivalent? Yes, they are equivalent set because they have the same number of elements. But are they equal set? Are they equal set? No, they are not equal set. Why? Because they don't have the same elements. We have H here and then we have O at the other set. Therefore, they are not equal set. How about this one? 1, 2, 3 and then in Newman numeral and then the other one, other set 1, 2, 3 in a number form. Are they equivalent set? Yes, they are equivalent set because we have the condition it should have the same number of elements. Take note of that one. If we are talking about equivalent set, it has only one condition. Jose Apolinario Andres and then Rizal Mabini Bonifacio. Are they equivalent? Yes, that it is still equivalent set because we have 3 on the first set and then we have also 3 elements on the second set. This one. We identify if it is finite or infinite. Set of grade 7 in USL. Is it finite or infinite? It is finite. Okay, so we have a limited grade 7 in USL. It has an ending. Next, set of fishes. Is it infinite or finite? That is also finite. Okay, next, set of males in USL. You have an infinite number of males in USL? None. It has an ending. Okay, so set of males in USL is finite. Next, how about set of females? That is also finite. Next, set of 7 wonders of the world. That is also finite. Next, true or false? I hope you can see this one. Sorry if I didn't darken it. Okay, true or false? Is ABC equal? What is the symbol for this one? This is equal set. How about this one? Equivalent set. Okay, take note of the difference. If we have equal sign, that is the symbol for equal. If we have curly equal sign, this means congruent, in other words. Okay, but since you did discuss that yet, we call this one curly equal. Okay, so this symbol is equivalent set. So next, set ABC is equal to set BOY. Are they equal set? Is it true or false? That is false. What is the condition for equal set? We have 2. It should have the same number of elements. Did number 1 meet the first condition, the same element? Yeah, the same number of elements. Yes, we have 3 elements here and then we have 3 elements here. But the second condition, it has the same elements. The number 1 meets that condition? No. So we have different elements. Next one, number 2. EYGHT is equivalent to PROVE. What is the condition for it to be equivalent? It should have the same number of elements. Let's count 1, 2, 3, 4, 5 and then 1, 2, 3, 4, 5. So are they equivalent set? Yes, they are equivalent set. Let's look at this one. Number 3. Excuse me. CALM. Oops, where's the cursor? CALM is equivalent to set is equal to set MILK. Is it equal? Is it equal? No, because they have different elements. Next, number 4, SORE is equivalent to ROSE. How many elements are there in the first set? 1, 2, 3, 4, and in the other set, excuse me, ROSE. Yes, they have the same element, therefore they have the same number of elements, therefore they are equivalent set. Next one, SORE is equal to ROSE. How? If the condition for it to be equal set, we have 2, they should have the same number of elements. Let's say, let's count 1, 2, 3, 4 on the first set, and then the second set 1, 2, 3, 4. So it meets the first condition. How about the second condition? They should have the same element. Let's see. S, we have S also there. O, we have O also. R, we have also R. And then E, we have also E on the last set. Therefore, they are equal. I hope you understand the different kinds of set.